welcome. So let's do some more problems. All right, so pictured at the right is the graph of f prime of x. At what values of x does the graph of f of x have a relative maximum or minimum? Justify your reasoning. All right, so remember, relative maximum, our graph of the function, not f prime of x, but f of x, would have to go, so this is for f of x, it goes from increasing, right, to decreasing, and then it has that horizontal tangent. Oh, isn't that a nice arrow? That would be our relative max. And then a relative min, it would go from decreasing to increasing. All right, so what does that mean in terms of the derivative? All right, so here f prime of x, let's squeeze that in there. I should have wrote bigger. So f prime of x goes from positive to negative. There we go. For a relative max, and then for a relative min. Oops. I hope I had a min up here a minute ago. So this would be the min. F prime of x goes from negative to positive, right? That's how we can tell we have relative max or relative min. So, let's color code the graph, and let's make the, we'll mark where it's increasing and decreasing, all right? So I'll mark it in green. F prime of x is greater than 0. F of x is increasing. Doesn't let you write off the board. All right, so that would be here, and then again here. So all these places, f of x is increasing, and then also here, because f prime of x is greater than 0. And then here, f prime of x is less than 0. F of x is decreasing. And that would be right here. And another important thing to mention is our candidates. These, the zeros for f prime of x, these are our only candidates for extrema values. All right, so our only candidates for extrema, and where f prime of x equals 0. And so that would be x equals negative 3, x equals 0, and x equals 2. All right, so now let's take care of the maximum first. So f prime of x has to go from positive to negative. So now if we look at our graph right here, f prime of x is greater than 0. Right here, f prime of x is less than 0. All right, so we go from increasing to decreasing right at x equals 0. So we can write that up. F of x has a relative maximum at x equals 0. So we might want to note that f prime of 0 equals 0. And f prime of x changes sign from positive to negative at x equals 0. We've covered all our bases. All right, we've showed that 0 is a candidate, right, because the value of the derivative is 0 at 0. And it changes from positive to negative. That is the relative maximum. Let's see if we can find a relative minimum. Right, so we already noted that f prime of x is less than 0 from 0 to 2, where it's below the x-axis. And notice here that f prime of x is greater than 0 at x equals 2. So that means that the derivative changes sign from negative to positive at x equals 2. F prime of 2 equals 0, so that is one of our candidates. And that means that our f of x has a relative minimum at x equals 2. So f of x has a relative minimum at x equals 2 because f prime of 2 equals 0 and f prime of 2, excuse me, f prime of x changes sign from negative to positive at x equals 2. I'll have to write smaller. I should have abbreviated because if g prime of x equals x minus 3 squared times x plus 1, determine on what intervals the graph of g of x is increasing or decreasing, and identify the values of x at which g of x has a relative maximum or minimum. Justify your reasoning and show your work. Now this is actually a little bit more advanced, and it's actually one of our later it's one of our topics in the second semester. Curve sketching, but I assume I put it in the notes because I've got it on this page. All right, so, and I've got it in this lesson. So I think we can handle this one. All right, and it's not, we've already got the derivative. So that's the, most of the work's been taken care of us, so it won't be too difficult. So we have the derivative here. Our candidates for extrema occur when x equals 0. Or excuse me, when f prime of x equals 0. Actually, sorry, this is g of x, g prime of x equals 0. All right, so that means that we need to find the zeros. My first step is to find the zeros of g prime of x, of the derivative. Well, that's pretty easy because it's factored. So we have 2, right? We have x equals 3 and x equals negative 1. That's it. Right? We just said x minus 3 equal to 0, and we said x plus 1 equal to 0. And we have our two zeros. So to know whether it's let me back up just a little bit. Our function g of x can only change from increasing to decreasing between those horizontal tangents, right? Because for you to go one way and then turn around, right, you've got to stop, right? Your derivative has got to be 0. You have to have a horizontal tangent. Right? So we've found the zeros. We're now going to do a sign chart to analyze the derivative. Right? In a sign chart, we have our key values, which in this case are negative 1 and 3. And we know that here the derivative is 0, right? Because we set the derivative equal to 0 and solved. But we want to know what's happening between the derivative. Or what's happening between. My shadow keeps blocking me. right? And it doesn't matter what value you choose. I need a value that's less than -1. I need a value between, because every single value on that interval is going to keep doing the same thing, right? Because the only times we're gonna be 0 is at -1 and 3. Right? So now we're just going to so I'm just going to do this mentally rather than write it down. But what I'm doing is we're plugging in the values into the derivative. Right? Maybe I'll write it up here just to remind you what we're doing. So here I'm going to replace the x with a -2. Right? So -2 minus 3, that's -5, but -5 squared, that's positive, that's 25. And I actually don't even care what it is. We just care it's positive or negative. So that's positive. -2 plus 1 is negative. A positive times a negative is negative. So if I plug -2 in, I get a negative number. Now it happens to be -25. But actually, we don't really care what it is. Right? All we care about is it positive or is it negative? Because we're looking to see, is our function increasing or decreasing? If I plug in 0, I have -3 squared, that's 9, times 1. 9 times 1, positive. Right? And then let's plug in the last value. And that's 4. 4 minus 3, that's going to be 1 squared. 4 plus 1, that's 5. Positive times positive, so that's going to be positive. Okay, so we just keep on being positive. All right, so now let's use our values of our derivative here to determine where our function g of x has a relative maximum or relative minimum. All right, so I'm going to switch colors here. All right, so we go from negative to positive. So that's an extrema. But notice here we don't change signs. We go from positive to positive. And I don't think I made an error there. Nope. No, because it doesn't matter if the first one's negative because it's got a square on it. All right, so we had two candidates. Right? Our candidates were -1 and 3. But this one is the only one that's actually an extrema. And this one is a relative min. All right, so now we're going to, let's answer where it's increasing and decreasing, and then where it has the relative min. So g of x is increasing on, and it's going to be between our zeros, right? So on -1 to 3, and then again from 3 to infinity. Now that 4 is not really anything special other than a test value. I could have chose 4, I could have chose 5, I could have chose 3.1. Every value that's greater than 3 is going to be positive. So our function g of x is increasing on -1 to 3 and then 3 to infinity, because g prime of x is greater than 0 on this interval. Hope I have enough space. I think I may need to extend the board just a little bit. That might be enough. Right? And then g of x is decreasing on, and so everywhere where the derivative is negative. So negative infinity to -1. -1 is where we switch. And that is it. Because g prime of x is less than 0 on this interval. And then finally, our relative minimum, relative maximum, in this case, relative minimum, g of x has a relative minimum. I'm going to have to expand the page just a little bit. I think that's good. At x equals -1. This is the symbol for because. I'm tired of writing because. Because g prime of x changes sine from negative to positive at x equals -1. And there we go. We don't have any other extreme values. So that's some ways that we can analyze a function using the derivative, and we'll do a lot more of this when we get to curve sketching. This was just kind of a little taste of it. And if you have any questions, let me know, and thanks for watching. Bye for now.